Hello and welcome to a video looking at autosomal linkage. We've already had a look at sex linkage, but the difference being that autosomal linkage is on non-sex chromosomes, so it's when the gene loci are present on the same autosome, they're often inherited together. And the difference as well is that these they're homologous, so they're the same, whereas sex chromosomes are non-homologous. And we say that the gene loci present on these autosomes are often inherited together. They are often inherited together, but they're sometimes not. And that is when crossing over has occurred, when we'll come on to that in a second. But when crossing, if it's unaffected by crossing over, here we can see that the chromosomes that they've not been affected by crossing over. So we can use the example of sweet pea plants, where the genes for flower colour and pollen grain shape are on the same chromosome. So we represent the flower colour has two alleles, capital P for purple and lowercase p for red. So we could have that capital P would be there, and also the gene for pollen grain has two alleles, capital L for long and lowercase l for short grain. So they're inherited together, so they'd be the same there, both dominant or lowercase p, lowercase l on the same chromosomes. They're inherited together because that's on the same chromosome. Chromosomes aren't separated, so that would be inherited as one unit. So we can see that if we crossed a purple flowered long pollen grain, so if we crossed a homozygous dominant with something homozygous recessive, then we I'll do that first actually. But what we can set it out slightly differently, just so we can remember that these have to be inherited together. So for purple and long, it would be capital P, low, capital L, capital L. But we're going to write it as capital P, capital P, L, L, because these have to be inherited together. And then we're crossing that with lowercase p, lowercase p, lowercase l, and lowercase l. These are inherited together as well. So we know that the first generation genotype, we know that it would be heterozygous. We know that. So we know that they're all going to be capital P, lowercase p, capital L, lowercase l. But we also know that they're going to be inherited together. So we know we've got to be capital P, lowercase p, capital L, lowercase l. So these are going to be inherited together, and these are going to be inherited together. And the phenotype, we know that they're all purple and long because they're heterozygous, they've got at least one dominant trait for that characteristic. And now if we interbred these first generation individuals, we know that we would have the only two possible gametes would be p, little l, capital P, capital L. Now, if these weren't autosomally linked, we would be able to have the other ones, but it's autosomally linked, we must inherit these together and these together. So we can represent this then. We know if in a Punnett square, we're going to have to have if we have here, we know we have to have capital P and a capital L. We have to have a lowercase p and a lowercase l. See, if that is one genotype here, this is what that is, a genotype there. And we're doing the same here because like that. And then here, capital P, capital L, capital L, capital P, lowercase p, capital L, lowercase l, capital P, lowercase e, capital L, lowercase l, and then all lowercase p, p, l, l. So we can see that here, all three of these are going to be purple and long. This one is going to be red and short. So if we're looking at the phenotype ratio, this is sometimes in exam questions they can ask you for two different kinds of ratio. So the phenotype ratio here would be 3:1. So we've got 3 purple and long and 1 short and red. But if we're looking at the genotype ratio, actually we've got 1 dominant homozygous, and we've got 2 heterozygous, and we've got 1 homozygous recessive. So it's actually 1 to 2 to 1 if we're looking at the genotype ratio. So there's 2 different kinds of ratios that we could have. Now, as I said, this isn't always the case with autosomally linked genes. So we can actually have crossing over occurring in meiosis prophase 1. So, for example, we have still got these where no crossing over, like they're unaffected, but here we've got these what we call recombinant gametes. Okay, so these are what end up in the gametes, and these are recombinant ones. So it could be that if we're using the same example, when we have got our first generation here, or whatever, we said that we would just have these like that and those like that. But here, some recombinant gametes are produced as a result of crossing over. So it could be actually that here, see, this is lowercase p, we could have a lowercase p here, but actually capital L there. So we've got lowercase p and capital L, and there we've got capital P and lowercase l, where usually we've just got lowercase p, lowercase l, and capital P, capital L. So this might be how, if there was an unexpected ratio of the phenotype, that might be what is causing it. So we could see that if so we could have more phenotypes being produced. So we could actually have, if it was PL like this, so if we had P, capital P, lowercase l combined with a lowercase p and lowercase l, then they'd be purple, flowered and short. But if we had lowercase p, capital L with lowercase p and lowercase l, then they'd be red and long. These are different to this, okay? However, they wouldn't be in the usual 9:3 to 3:1 ratio that we would expect if the genes were not linked. And it's important to remember as well that the further apart the 2 gene loci are on the chromosome, the greater the chance of recombinant gametes forming. So that is it really for this. We've just got to remember that I would recommend displaying it like this, so that we know that these have to be inherited together. unless of course crossing over has occurred, in which case there will be a difference. Anyway, thank you for watching.